Good afternoon, folks. We're going to go ahead and get started. My name is Josh Joyner. I'm the product manager of the ArcGIS GeoEvent Server. I'm joined today by Adam Mollenkoff, the real-time and big data GIS capability lead here at Esri. We're going to present today on ArcGIS and the Internet of Things. Several topics we're going to get through today, so quite a bit of content here. We're going to start with just kind of introducing, what is the IoT. Make sure we all have kind of a same starting point here as far as the possible definitions and applications of it. We're going to take a deeper dive at kind of decomposing what's a part of an IoT solution, look at a few different deployment patterns, take a much deeper look and specifically of how ArcGIS can be used as a part of an IoT platform, looking at some of the applications, particularly regarding the spatiotemporal analytics that are capable with an IoT data, looking at some scale requirements for handling IoT, and then we're going to leave you with some additional resources and some time at the end for questions. So to start with, we want to kind of answer the question. We have a session here on IoT. What is the IoT? I know it's one of those kind of buzzwords you probably hear a lot in the conferences, throughout the week. But there's several different possible definitions of it. So I want to kind of start with a very technical definition. This is one that's from the analyst firm Gartner. It says, the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. So that's a very IT-focused definition. It's very focused on the technology, the actual, the hardware involved and connecting with the different devices. And so probably for a lot of us in the room that kind of work in that space, that's a very common definition. But there's another set of definitions, and it really depends on kind of what background you come into this. And so if you ask different people what they think the IoT is, it's going to be vastly different depending on kind of what their application side of it's going to be. So, for most consumers who, want to know about IoT, what they think about is like connected homes, smart appliances, being able to control my thermostat from my cell phone. Maybe before I leave the office, I can turn my lights on, turn my lights off. Very consumer driven. For a utility company that's working in this space, it's going to be network sensors along their transmission lines, their pipelines, wireless meters that make it easier for the utility workers to be able to kind of read those values instead of having to walk door to door and manually get those values. From a local government perspective, it's a different story as well. From there, it's being able to monitor the real-time positions of the emergency services folks or service requests that come in, or maybe it's embedded sensors in roadways and bridges, and so being able to get a better kind of live view of the infrastructure they're working with. There's a lot of application, of course, in the military space for IoT, so that could be things like troop movements or, again, real-time sensors on the ground. Maybe it's noise sensors or vibration sensors you're wanting to detect motion. There's a huge use of IoT in the agriculture space. So these are sensors that are maybe in the ground that are detecting the amount of rain or soil chemistry. Maybe it's tracking farming equipment, or to be able to kind of automate things like automatic sprinklers, control the amount of resources they want to use. There's applications in different transportation, communication. There's a lot of IoT space in things like natural resource monitoring and disaster alert response. So, am I listening for, flood surges or high winds? We're also seeing a huge growth in the just more commercial space with IoT as well. So more of a kind of a transactional, we want to kind of monitor for, different changes in markets. But when you're talking to users about IoT, odds are they're probably going to come back with something like this. This is the application side of the Internet of Things. You're going to see buzzwords, keywords, things like digital pipelines or intelligent logistics, connected cars, health, home, precision, smart cities, smart communities. It's a very application-focused approach to it. But the point being that while the concept of the IoT might be a relatively new thing for some people, a lot of these ideas are not. These have been things that odds are you've probably been working in these spaces for several years now, but there is certainly some shift occurring that we want to make sure that we understand and we're all kind of on the same page with. So I'm going to do now is I'm going to hand it over to Adam, and Adam's going to kind of start talking through kind of what's a part of an IoT solution, really decomposing that solution.
All right, so I get the privilege to work with a lot of Forrester, Gartner type analysts and other folks, and so I've kind of decomposed like what all these industry analysts are talking about from an IoT perspective and come up with this blueprint. I'm going to kind of walk you through incrementally through a blueprint for IoT solutions. So this will kind of decompose down what an IoT solution consists of. And then we'll take that and map our ArcGIS stack to that to see how it compares. So another definition of IoT is basically an integrated solution that senses and collects data from devices, those devices having sensors. At the edge, it analyzes that data and it takes some type of action to accomplish a business goal of an enterprise. And so if you look at an IoT solution, there's typically 3 layers involved in this IoT solution. So it consists of an edge where the device and the sensors would live. So that's out close to the things. There's an IoT platform, typically that lives in the cloud. And then there's enterprise, which is where all of the data that's gleaned out of the IoT platform becomes visual and useful from a dashboard perspective that informs businesses so that they can take action and do appropriate things with it. So the edge is responsible for sensing, acquiring, and disseminating the data about things that you're interested in, all those things that Josh had on the slide a minute ago. And the IoT platform accepts this, it ingests it, it sometimes stores that, and analyzes that either in the stream of data as it's coming in, or it could analyze that after the fact once it's stored on a periodic basis. And the results of that analytic would be shared as intelligence that can be used by the enterprise to make decisions or to perform actions. And then on the enterprise side, that's basically where that intel is used to do things and make actions appropriate. So the edge, if you break it down a bit further, excuse me. If you break down the edge a bit further, is basically all about the environment. So this is the real world that we're trying to model, the real world that we're trying to understand, and the real world that we're trying to affect. And so this generates real-time observations from the things that we're interested in. And these are sampled by sensors that are converted to information by devices. So a device, otherwise known as a thing in the Internet of Things, is something that sits at the edge and has sensors attached to it. It could be one sensor that's just collecting a CO2 measurement, or it could be hundreds of sensors that are on one device. Each of those sensors are typically sampling the environment, about 1,000 times per second or so, and it's collecting this information that devices assemble down to something useful that they want to transmit to an IoT platform. And that could be transmitted either through a communication protocol that pushes the data to an IoT platform, or the IoT platform could reach out to the device and request information about it periodically. And so the devices can be smarter devices as well, so they don't constantly transmit the same information over and over again. So there's thresholds that you can set on devices that say, don't tell me again until you've changed your behavior by this amount. So that could be gas pressure in a pipeline. And so if it hasn't deviated from a certain percentage from the last reading, we don't necessarily need to know about it. So we want to limit the transmission. Or it could be if something moves X meters in X seconds, we want to know about it when it moves, but we don't necessarily need to know that it's in the same location continuously every second. The biggest aspect that people typically don't understand in the IoT is the actuation part of this. And so these devices, while they can sense what's happening in the world, also have capabilities to change their behavior through commands that could be sent to these devices. So this could be, I've detected a gas leak in a pipeline, so go shut the valve down in front of it. So send a command to actually do that, or roll my window down on my car, or start my car, or unlock my door. All these different actuation commands that can be automatically sent from an IoT platform, or it could be used from a business perspective where somebody makes a decision about what to do and physically issues a command to do that. So a lot of these devices are starting to have actuation commands to actually adjust their behavior in the environment. So it's all about collecting information about the environment and adjusting the environment based on that information. Now, as far as communication protocols that are typically seen in this space. Devices typically transmit over one of these 4 protocols. MQTT is a IoT standard. It's a message queuing telemetry transport that's very lightweight, and so this allows you to send lots of data over a push channel to an IoT platform. HTTP is very common as well, which we're all familiar with. And this can be used as a push to an IoT platform, or it could be used as an endpoint on the device that IoT platforms hit and do something with. And there's a couple other protocols. The Advanced Message Queuing Protocol is kind of like a bigger superset of MQTT and has some more advanced capabilities. And then CoAP is more of a constrained protocol for devices that are really limited in their network ability. So another option at the edge, and we're kind of decomposing this down and showing you details of the edge, is that there can be gateways that sit at the edge. And so some people call this fog computing. So this is where reasoning might happen with a collection of devices. So a gateway could sit inside a vehicle in a connected car solution, and that vehicle could be making local decisions about what to do. And so there's a gateway in the car that's collecting its own sensor information, making decisions locally about what to do, and the gateway could decide this is important information, there's a slippery condition, tell the IoT platform so that other cars that might come in that scenario could be notified. And so these are also known as aggregation points. These are also useful for managing the devices that are out in the field. So firmware updates, security protocols, all of those things, which we'll see more in a minute. But it serves as a primary interconnection to the IoT platform. Now, typically from a gateway to an IoT platform, these 2 protocols are the most prevalent, MQTT and HTTP. And so while the devices may only have the ability to communicate CoAP or AMQP or maybe some legacy protocol, the gateways have the knowledge and the logic to be able to receive that communication protocol translated into something that an IoT platform can consume. And so with this, IoT platforms really only need to deal with a subset of the messaging that's happening with the gateways employed. So device management is another huge aspect of an IoT platform. And so this is about communicating in a secure way. So if we're going to be shutting pipelines down and opening doors based on proximity and things of that nature, we probably want to make darn sure that it's actually the right person to do that for. If we shut a valve down and we receive that command on our valve, the valve wants to know that it's coming from a trusted source. So security is of the utmost importance here. And so an IoT platform is responsible for providing device management, where we can put security certificates on the device and on the IoT platform, and that we can trust each other to do this. But it also is responsible for keeping devices up to date, provisioning their software updates as appropriate, and managing those devices out in the field. The next couple pieces here are ingestion. And so an IoT platform, now that we've talked about the edge communicates the data and disseminates things that are happening in the environment. And the IoT platform is responsible for ingesting that data in some form or fashion. And typically there's streaming analytics that can be attached to that ingestion, 1 or more of those. And so from a streaming analytic perspective, this can consume a continuous stream of data coming from things out in the environment. And there's orchestration and policies that get configured in that streaming analytic that says, here's the model of behavior that I want to detect. So when there's this pattern of interest, I want you to trigger an immediate action. That action could be notify me on a map, it could be send me a text message, or it could be send a message to the device that's an actuation command to affect its behavior. And so this is super important in the aspect of an IoT platform. The actions and intelligence can actuate the edge devices, or they can fire off things in an enterprise application, such as a map or a dashboard. Typically, there's a data store that's part of an IoT platform, and so this is important to be able to replay things that happened out in the environment. So maybe something happened and we didn't really watch it before it happened, and we want to go rewind that and see what happened on the map. And so this is almost like a film strip of observational information about what's happening in the environment. And so this prepares the data for very efficient visualization, interactive querying, and also prepares it for quick batch analysis. The batch analysis is responsible for doing prescriptive or predictive analysis on the data. And so this typically runs on a periodic basis. So maybe I want to track these moving assets that are moving around. But instead of just showing breadcrumbs on the map, I actually want to draw a line between their last known locations. So maybe I want to apply a reconstruct tracks analytic that runs every 5 minutes, every 1 minute, so I can see the lines behind the individual trails that are happening. Or maybe I just want to aggregate information about what's happening so I can see where the population density is of some phenomenon that I'm tracking. The last couple pieces of the IoT platform are the management console. And so this handles things like management task of the IoT platform. So how do I configure the flow of data? So how do I configure a streaming analytic? How do I set up policies and my business rules to do things that I want to affect? And then what are the event thresholds and how do I manage my data stores? The policies are the rules of what we've been talking about, and then the orchestration is coordinating the steps necessary to execute some type of action. And the last piece here, from the IoT platform back to the edge, is that blue line on the bottom there, which is an actuation command that we can make a decision on. That could be a result of a streaming analytic detecting a pattern of interest, or it could be the result of a batch analytic detecting some pattern that we want to affect behavior in the environment. And then also when there's a gateway present, then the actuation command would go to the gateway, and the gateway serves as the mediator to send that command to the device. Last piece here is the enterprise layer, and so this is typically where visualization would happen. So this is where our map services, our feature services, our stream services would be readily available inside of a dashboard app or some other type of application that we would see. And so we can visualize trends, we can recognize that policies have been created and automatically detect those things and trigger actions. The dashboards are configured and enable the monitoring of a IoT solutions environment and the behavior of its devices and things, as well as its history. So I can go back and replay and rewind. So that's the overall blueprint for an IoT. And if you summarize this, there's 9 or so categories of capabilities that an IoT platform needs to bring to bear to call itself an IoT solution. And so if you map this to our ArcGIS platform, we actually do a pretty decent job to handle most of these capabilities. So from an ingestion perspective, we allow input connectors in GeoEvent Server to bring data in from a real-time perspective. We have our GeoEvent services that serve as our streaming analytic policies. Our actions are the outputs of GeoEvent services. And then we have the spatiotemporal big data store that serves as our layer to store this information. GeoAnalytics server that was introduced at 10.5 allows you to do parallel analytics on large data sets that's either stored in the big data store or connected to your external big data file shares. And then our management console for this application is Portal and the GeoEvent Manager, and even Pro for executing GeoAnalytics jobs as well. And then from a visualization perspective, our operations dashboard and insights and story maps are common things that you would use with an IoT solution. And those underlying dashboards would use map and feature services that are resulting from the IoT platform generating those results. And there's a whole bunch of other dashboards. You could even consider Pro a dashboard for somebody that's doing analysis from a GIS perspective. So this has been interesting to follow this over the number of years since we've introduced GeoEvent. I think that was introduced in July of 2014. And so when we first introduced GeoEvent at 10.2, the common use cases were I want to track snowplows or I want to track police crews or other folks of that nature. And what we've seen over the last couple of years is that we start to have a new class of customer that's needing to track just about everything you could imagine. And so this is where a lot of these smart city, smart community, smart nation type of environments start to look at all of these various aspects about their environment that's happening. And then they want to be able to actuate things in that environment. So if we can detect, bad chemicals in the air, we might want to do something about that. Maybe we dispatch somebody to go look at the situation. If we detect weather, we might want to alert citizens. So there's all kinds of different applications within the space. Now, from an IoT platform perspective, the one area that we don't cover and really have no plans to cover is the device management aspect of this. And this is just because of the wide variety of different devices that people would want to connect to this system. And so for folks that want to have this secure device management and actuation capabilities, we typically complement other IoT platforms for that capability. And so this is where, if you take Azure as an example, the white boxes represent Azure components that complement the existing IoT solution that we've kind of presented before. You could substitute those white boxes from Azure with Amazon IoT or Cisco IoT or Huawei IoT or any of the other 12 or so IoT platforms that are out there. And so the edge of this would basically be communicating into an Azure IoT or underscore IoT platform that you choose. And that IoT platform would be connected into GeoEvent Server, typically through input connectors that we have. So we have connectors for a large variety of these different cloud providers. And then results can be sent back to Azure as well. And so this is where, if you saw the keynote this morning about all the really cool machine learning and the other stuff that's happening in the Azure space, we can actually complement these platforms together. And so we've done this at a number of customers where there's real-time and data coming into Azure IoT. They want to geospatially enable that with our spatial temporal capabilities, and we detect geofences, other things, and then we alert back out to Azure IoT. But we also store this data in a common place inside of the cloud such that Azure machine learning tools can pick that data up and do things with it. And so there's kind of this symbiotic relationship of collect the data, do analysis on the data, do spatial temporal things in real time, but do machine learning and then do additional spatial temporal things. Maybe I want to enrich the data with additional geospatial components so that when I run an Azure ML component, it has that to consider. And so there's this back and forth that can be exchanged where we complement these things. So when people ask us about, well, what do you think about Azure IoT or Amazon IoT? Our answer is they're awesome. They complement what we do within ArcGIS, and they solve a problem that we don't, which is the device management. They as well have additional capabilities like streaming analytics and other things as well that also complement us as well. So you can use these in concert with each other to do deeper things. And when we do this with Azure and Amazon, they typically don't look at us as all those pieces and parts. They look at us as just adding spatial temporal capabilities to their platform. And so there's a lot of work that we're doing with Azure and Amazon and other folks to enable this integration with this. And you can see this today with our connectors that we have with GeoEvent. So with that, I believe you're doing this section, right?
Yes, please.
Okay.
You can switch over. So I'm going to take a little deeper dive at kind of the one specific architecture that Adam was describing. And this is really using ArcGIS as an IoT platform. So when you look at ArcGIS as an IoT platform, really ArcGIS Enterprise has the support to do both real-time and big data capabilities. We do that through three components, primarily. That's the GeoEvent Server, the GeoAnalytics Server, and the shared spatial temporal big data store. Within these capabilities, GeoEvent Server provides the capability to do kind of the real-time, high-velocity ingestion of IoT data, so it allows you to connect to all these different data sources that Adam mentioned, the edge devices, whether it's connecting to the devices individually, whether it's connecting through some sort of gateway, some sort of aggregation point, or whether it's connecting to one of those other existing IoT platforms. What we do with GeoEvent as well is we can perform kind of real-time continuous analytics on the data as it's being received. So this is different from some more traditional types of GIS analysis where you're going back and looking at a day, a week, or a month's worth of data, and you're doing some sort of analysis looking for patterns. With this, you're actually trying to configure it so that we're looking for these patterns as data is received in real time, so that you can then act upon that when you identify, whether it's, Adam mentioned, we want to do some actions later on. Well, what are we looking for to detect for those actions? How do we know when something is occurring? So if it's, you're looking at temperature value, we want to know not just the value, but where it is and what pattern are you looking for. We need to be able to provide a way to store the data. So for that, within our platform, we do that through the spatial temporal big data store. We can also do writing back out to more traditional relational feature services. The challenge becomes an issue of scale, which we'll talk a little bit more about as we go along. But typically, when you're dealing with IoT data, you're looking at a much higher velocity, higher volume of data. Excuse me. So we also need to be able to find a way to visualize that. And we do that through the rest of the ArcGIS Enterprise as well, and as a part of the spatial temporal big data store, that we can visualize this high volume data either as aggregation features, so we can actually do bins where it shows either a count or a statistical value of the data that's collected in a given area, or as discrete features. And when we do detect some sort of pattern that we're interested in, we need to find a way to do notification. So we do notification be either writing back out to a feature service, we can be sending text messages, sending email, some sort of alerting when that pattern is detected. But I think more importantly with the IoT platform is that actuation, being able to send something back out to the devices in the field to be able to directly affect the environment. So it's not you get a call at 2 in.the morning that there's a problem going on somewhere. Now you still may get that, but the point is we want to try to correct those behaviors automatically. So if there's a problem going on and there's a fire occurring, we want to go ahead and activate the sprinkler, not tell you there's a fire. We want to go ahead and try and address and impact those things that are affecting the environment. So when most people kind of come to the table and thinking about IoT, they think about smart city, they think about smart community, and that's a very important space. But if you look here at an example, we actually have customers in almost 1,300 organizations in 90 countries that are using this technology, and they're in industries across the spectrum, from commercial services to healthcare, defense services, public safety. Of course, we see huge applications within the utility space, things like when you're monitoring water and gas and electrical sensors because they're wanting to monitor the flow of these power things. Seeing it in transportation, also seeing huge applications within nonprofits for conservation efforts, and at all levels of government across the board. So one of the things we also provide in addition to all these different applications is IoT and ArcGIS in general provides access to levels of data that are on an entirely different scale from what most people have worked with. So a couple examples of that would be, this is one, we have a partner called FlightAware, and FlightAware is able to provide tracking of over 25,000 flights worldwide at any given time. 250, what did I say? What did I say? 25. Oh, I said 25, yes, 250,000. Yeah, a little bigger than I was thinking. And in real time, this data is coming through, and this is data that you can subscribe to and you can use in conjunction with your data feeds, and you can see the patterns of movement of these flights worldwide. We also do similar feeds coming through from the sea. So 150,000 vessels worldwide being tracked by Exact Earth. This is AIS ship data. So if you're looking at patterns of goods as they're being shipped from one country to another, it's an entirely different scale of data, but allows you to kind of take that information and identify patterns. We also do similar data feeds coming through on the roads as well. We partnered with Waze about 2 years back. Waze has over 1 million users worldwide, and we're able to get global traffic feeds, and not just at here's traffic and it's going to take me a half an hour to get to work or something like that, or how do I get from my office to the house, but actually being able to provide in-depth data on the different possible causes of delay. So if there's an accident that occurred, it allows users to report things like different hazards on the roads, different things that can actually be utilized back by these communities. And it's a great way for a lot of our customers that are working with it now, particularly through the use of Waze has this program called the Connected Citizens Program. And it's a free program that allows municipal partners to share authoritative data back about things like road closures. We have an event coming up and we need to close this section of the road. And in return, Waze shares back with those communities all the information that Waze collects on a continuous basis about their community. So it's a great kind of two-way data sharing that allows kind of a lot of organizations that want to start getting into some of the IoT space and access to some of these big data feeds. And these are getting used for a lot of different things. Here in California, they were used heavily in 2017 by the USGS in conjunction with Waze with tracking some of the wildfires that occurred. So this is a two-way communication that allows for both Wazers, that's the Waze users, to report fire, so it gives you some extra eyes on the ground, but also it allows Waze to share the information back about road closures, and fire is a living thing that as it changes, closures need to occur, and in terms of public safety, we need to make sure that drivers aren't going down a route all of a sudden there's fire in the way, and we need to quickly reroute folks. So in terms of what we can bring into the ArcGIS platform out of the box and then through GeoEvent Server, we have three different kind of groups of connectors that we work with. So on the left are out-of-box connectors. These are typically the more generic types of data feeds that we want to work with. This will be being able to connect to most of your external vendor sites. You can bring in data feeds of JSON, GeoJSON, CSV file, XML data. If you're polling an external website or you're exposing some sort of REST endpoint where you can have data pushed to you. Also, if we want to communicate with the rest of the ArcGIS platform where you're wanting to poll an ArcGIS server or you're wanting to subscribe to a stream service, you can bring the data in as well, or listen to an RSS feed. You can bring in those things, as well as just reading from local files. In that center category here, we have our Esri gallery. These are kind of add-on connectors that work with the GeoEvent server and allow us to connect to some of the more common third-party data feeds. Some of these are things like GTFS, which is for tracking bus feeds. There's several ones that are kind of more military-focused, things like Cursor on Target. There's social media things like Instagram, Twitter. You can bring in big data feeds from Kafka or NMEA, or some of the GPS devices, Sierra Wireless, Trumbull, things like that. And we also have our partner gallery. That's those on the right. These are ones that we built in conjunction with these service providers, things like Exact Earth and FlightAware that I showed a minute ago, as well as those connectors for the Amazon IoT Hub and Azure IoT Hub that Adam was showing earlier, being able to integrate directly with those providers and share data seamlessly between them. Now, the nice thing about and why we keep these as kind of separate gallery items and not put them all within the same out-of-the-box product is if one of these providers changed their API tomorrow, we wouldn't want our users to have to wait 6 months for the next release to come out for us to be able to continue to let you use your data feed. We want to be able to fix these things off cycle, and so we can kind of keep your data flowing as much as possible. Now, once we've ingested the data, once we've brought that IoT data into the GeoEvent server, there's several different things we can do to kind of control the flow of that data. So an example here, you can see we have two different inputs that are coming through. We're sending it through a series of processors. So we're filtering it first, spatially looking for incoming data that has a geometry inside of a specific zone. We can modify the geometry. We can take that point geometry and expose it as a buffer. We want to create a larger service area. We can send it out to one output. We can create geotagging processors where it enriches the value, the data coming in with other values coming from some shared geometry. We can apply a motion calculator. So if you want to do some processors, some statistical analysis on the data coming through, we can apply that. But it really allows you to kind of enrich that data coming through and add additional value to the raw data that's being received. So there are several different types of kind of streaming analytics and processors that we can utilize within GeoEvent Server, some of which I just mentioned, things like doing the buffer creation. But you can also do the geotagging where it's adding the names, it's enriching the values. When you're comparing geometry of an incoming feature with the stored geometry in a geofence. You can also do a lot of the same types of field calculations and modifications that you can do on the data within ArcMap or ArcGIS Pro, where you're doing field calculations, where you could have data coming in, it's in miles per hour and you need it to come out as kilometers. You can apply a formula so that all the data coming through gets applied for that. You can also do different types of pattern detection, so something like an incident detector, where you can set up a series of filters and triggers and things you're looking for, and you can set you're looking for attribute values or spatial values or even time values. How long has something been ongoing? If you were looking at a temperature sensor in a given area, you could say I want to be alerted whenever the temperature goes above 100 degrees. But if it's right at 100 degrees and it's only there for a few seconds and then drops back down again, that's a different level of perhaps, concern of if it's above 100 and it stays there for, an hour or something like that. So you can set different types of control. Now on the output side, just like we have on the input, we have two different groups that allow you to do out-of-the-box connectors. So you can connect directly to all the rest of the ArcGIS platform through things like add and update features. If you're using the spatiotemporal big data store, you can add and update features directly to that. That's using a TCP connection, so it's going directly to the data source. Excuse me. You can also do notifications through text messages, email, instant messaging. Or if you're using, like we have before on our gallery, if you have an existing Hadoop setup and you want to send stuff out to an existing big data storage solution, you can do that. Send it out to Kafka. Or as commonly the case, if you want to send it back to your IoT providers, we can send the data back to Amazon or Azure for use with some of the additional kind of BI tools that are available through those platforms that Adam showed earlier. So in terms of the types of data that we're actually getting into the IoT platform, they typically kind of fall into one of these three categories. So for most people, when they think about any kinds of real-time observational data, IoT data, the logical thing is moving things. I'm thinking about something that I can actually see moving around on the map, and that's some sort of a plane or a car, or I'm tracking an animal or a storm, something that's physically moving on a map, and we want to be notified of when it enters one area or how long it's been moving a certain direction. In the IoT space, we see quite a bit more on the stationary type of data, though, where the actual assets themselves aren't moving, but they're continuously transmitting data. So you might have a stream sensor or a buoy that shouldn't be moving, but it's continuously sending out information about water levels or wind speeds, air quality. That's a very, very common IoT space type usage. And the third category is really those discrete features, something that just happens. These are things that only get triggered when a certain pattern has occurred. And this is typically engages some of the fog computing that Adam mentioned. There's some sort of perhaps logic on the edge device that when it looks for a certain pattern. So when that occurs, we want to be notified of it. So it allows you to have kind of a combination of the first two sometimes. You're able to kind of set up and look for certain patterns. And when it occurs, wherever it occurs, we want to be notified of it. From a storage side, we have several different ways of storing the data. The primary one for the IoT space is when we're writing it out to our big data store, the spatiotemporal big data store. And that allows for 4 different types of indexing to occur. The first one is geohashing. This is based off of coordinate values, so it creates kind of a rectangular pattern within the given geometry. We also do square, as well as pointy and flat hexagons. The hexagons and the triangles offer additional benefits over the geohashing and square patterns in that they allow for better curvatures. So they allow for more kind of realistic shapes and much tighter geometry orientations. Now the nice things about using this kind of a platform is not just that it gives additional visualization capabilities, but it also, when it's storing the data, it's providing a temporal index on the field, as well as an inverted index on all the attribute fields. And what that means from a functional standpoint is, as the data is being written into the system, it's indexing it on a number of different parameters. So it's indexing it on the attributes, it's indexing it on time, it's indexing it on location. So when you're trying to query this data, you're working with it after the fact. It's one of those kind of unique scenarios where actually the more complex of a request that you make, the faster response time you're going to get. So that's one of the challenges when you're storing quite a bit of data is, if I'm collecting 1 million features a day and I need to go look for something that occurred last week on Tuesday between these hours at this location, and you have several million records, you don't want to have it crawl through all those millions and millions of records to look for something that matches each of those categories. The way we're doing all the different indexes, you can look for something that Okay, I know it happened on Tuesday. Great. So out of my multi-million point data set, now I'm down to, a few 100,000, maybe 1,000, because that just happened on that one day. And then you could further isolate it based on the time of the day. So it's even a smaller chunk of data to search against. If you know where it occurred, it's an even smaller set. So you may have started with several million features to begin with, but ultimately you were only querying against an index of a few hundred features. So you're actually, you can get kind of sub-second response times for this. So it provides very, very performant visualization capability. It also provides the ability to do visualization as either discrete features like you see on the right or as aggregated bins on the left. And this can show either as the count of features that are in a given area or as some sort of statistical value. And I think that's actually for a lot of usage in the IoT space, that's actually probably the more beneficial. So you might have a temperature sensor that every few seconds reports a given value, but if you were to go back and look at that data, you don't really care how many times that sensor has updated. You want to look at what was the average temperature it actually returned, or what was the max value it returned, or the minimum value. You want you want to actually gain knowledge based on the summary of that, some sort of statistical calculation of the data, not just the raw count. So you can set it to either way. But this is actually real data. So if you were to enable pop-ups on those bins, you could click on any one of them and actually, in this case, scroll through 233 different features that were included in that particular bin until you to see all the raw data. So the point is that it gives you access to all of the different underlying information here. So I'm going to hand it back over to Adam, and we're going to take a look at some of the different types of spatiotemporal analytics that can be applied to the IoT data.
All right, so this is the batch analysis part. So this is what can you do with the data once it's been stored inside of the big data store. This also can be done with external big data file shares that you may have as well. So if you have an investment in HDFS or Hadoop that you already have, this can certainly connect to that environment. Or if you just happen to have a collection of shape files or delimited text files in a folder that you want to analyze, this is also capable of connecting to those as well. But typically in this IoT scenario, the data that GeoAnalytics is running against is data that's been collected through the GeoEvent Server. So there's 5 major categories of different analytics that you can run currently with GeoAnalytics Server. There were a couple that were added at 10.6. I think it was detect incidents and calculate field were added at the 10.6 release. But you can summarize data. This can be with additional aggregation capabilities beyond what Josh was describing before. So while we have all this on-the-fly aggregation capability with the feature services and map services that run on top of the big data store, we also have additional aggregation capabilities within GeoAnalytics. And so why would you want to aggregate points with GeoAnalytics? Well, you might want to aggregate into polygons. And so we don't do on-the-fly polygon support as of yet with the big data store. So if you want to do polygon aggregation, GeoAnalytics is your tool for doing that. And GeoAnalytics Server, as I mentioned before, allows you to run analytics in a parallel way. And so this is using Apache Spark underneath the hood, where we've added additional user-defined types and user-defined functions to GeoAnalytics to extend Spark's capability to do spatial temporal. And so these are the tools that we have. Reconstructing tracks I mentioned before. Joining features is actually quite powerful. We're going to deep dive into that one in just a second. But also detecting incidents. So maybe I want to detect when some condition occurred and I want to keep track of how long it occurred, but I want to do that in a batch analysis. So I go back and look at yesterday's observations, and then I want to keep track of how long was somebody outside of a boundary of interest, or how long were 2 people co-traveling with each other, or other scenarios that you might want to track. Finding hotspots is quite interesting. So if you're looking to just understand the population of IoT things that are moving around, you can run a find hotspots and start to scientifically discover what's happening from a population distribution. Or you can simply calculate fields where you might want to enrich the data with additional things. And this calculate field implementation actually leverages the arcade expression language as well. So you can go in there and plug in arcade expressions into that calculate field. So for the purpose of this session, I was going to talk a little bit more detail about these 2 tools because I think they complement the IoT discussion that we're having quite well. And so aggregate points we talked about already. This might be that I want to look at the spatial distribution of vehicle collisions and how they've changed over time. And so we know how to aggregate points into bins today, but how do we aggregate points into bins with a temporal dimension? And so that's what geoanalytics provides, is this additional temporal dimension, but also being able to do this on really high volume data sets. So if you've got tens or hundreds of millions of observations stored inside of the big data store, this can perform that analysis quite quickly. Or maybe you have zip code or postal code boundaries and you want to understand the highest count of crime incidents within that area. Or as Josh mentioned, you can actually point to a field and look at average or minimum or standard deviation statistics of some phenomenon that you're trying to track. So as far as the tool is concerned, the input into aggregate points is a point observation layer. And so that could be a feature layer that's inside the big data store, something that was collected through the IoT. The input too is either polygons of interest that you want to aggregate into, or you could just generate bins, and these bins could be specified by a certain distance tolerance that you want to define. The output of this are polygons that represent the aggregated result, so they have a weight against them that describes the aggregation. And if you're doing it into bins, it could be a square grid, a hex grid, or if you specify polygons, you can get your polygonal feature back. And users can choose to aggregate these either spatially, or you can add that time dimension as well. And so if you do this from just a spatial perspective, this is what you would typically get. So you start with points, and then you aggregate into some bin that you specify with some meter resolution or whatever unit you want to use, and then you get a square output. You could do the same with hexagons as well. And then spatial into polygons would represent polygons with the weighted distribution. If you add the temporal dimension to this, though, you can get both a space-time cube as a result. So if you're using squares, you can get the space-time cube. And you can also, if you're using polygons and you're adding a temporal dimension, get a space-time volume. And so that would be the polygonal feature on the right-hand side there. So that vertical axis is time, whereas the other dimension is x and y, the space aspect of it. So this is quite interesting because if you look at the space-time cube, you can really start to understand the distribution of some behavior that's happening with your things on the IoT, and you can see where the distribution of those events are occurring. Join features is probably the most versatile and most comprehensive tool that we have because you can do very sophisticated things with it. And so this might answer some questions like, which bodies of water intersect cities with populations that are greater than 1 million people? And so you can combine space, time, and attribute queries together all in one join. And so the example here is the input could be any type of geometry, and the output is, or the second input is any other type of geometry as well. But the output are any type of geometry as well. So you can join anything to anything else and get that geometry out. But the interesting thing here is all the different aspects of how you can do this. So from a spatial perspective, you can join spatially with all these topological operators. From a temporal dimension, you can join by all these temporal operators, which are quite interesting and fascinating to think about. So I can do, how many accidents were started by some other incident that happened just before that. And so, or more interesting, tell me something that was near in a temporal dimension, and near in a temporal dimension, and near from a spatial dimension together. So you can really start to answer some pretty sophisticated questions with these joins. And then you can also match that with any attribute query. So tell me when there were two people near each other spatially, and then within time they lingered with each other for a certain amount of time, and they were also Android users or something of that nature. So you can start to really join this all together how you like. Another way to view the temporal operators is visually, and so this shows some of the temporal relationships of ended by or near. So as far as handling IoT scale requirements, Josh is going to walk us through this.
Thanks, Adam. So when we're looking at this from really an IoT perspective, and when we're looking at specifically in the ArcGIS Enterprise side, there's several considerations that need to kind of be brought in when you're looking at kind of architecture. So from a minimum environment, when we're setting this up, you're looking at a minimum of 4 machines to be able to support real-time and big data GIS with the ArcGIS Enterprise. You're going to need one machine at least for your ArcGIS Enterprise. That's portal, ArcGIS Server, your web adapters, some sort of relational data store. You're going to need a machine for your GeoEvent Server. You need to have a dedicated machine for the spatiotemporal big data store, and a fourth machine for the geoanalytics server. And so that allows you to ingest both the IoT data through GeoEvent Server, as well as some of the bigger kind of batch loads available through the geoanalytics server. Both of those are be able to kind of, they can work off the same data sets within the spatiotemporal big data store. Now, our be able to kind of capabilities, kind of a scaling story within GeoEvent, specifically has improved with every release of the GeoEvent server. Starting with the 10.2 release, at that point we're able to bring in about 500 events a second, compared to the new 10.6 release that came out back in January. They're now up to support up to 6,000 events per second per instance of GeoEvent server. And this is important to understand because as you begin to scale up in the kind of the different types of IoT data you're bringing in, you're no longer, if you're not just tracking a few hundred snowplows in your city, but instead you're tracking the, tens of thousands of or thousands of different sensors that you're trying to bring in over the same given area. It's a different scale. You're going to need to have additional machines, additional resources to be able to support that. So kind of an example of an optimized environment that will allow you to handle some of the IoT scales shown here. It's a little bit more to handle as far as kind of setting it up. This would be kind of 10 machines. So you still have your single machine for the ArcGIS Enterprise. You can scale up and have multiple instances of the GeoEvent server running. You can have multiple nodes running within the spatiotemporal big data store, as well as multiple instances of the geoanalytics server. So on the geoanalytics side, as there's certain kinds of batch processing and analysis you're wanting to do, you may need to have additional machines to be able to support the complexity of the data, the complexity of the request being processed. And on the GeoEvent side, being able to support either the higher velocity and the throughput as we talked through. One of the things we can do now is with the multi-machine deployment support that we added with the 10.6 release, you can scale this up. So you could potentially have up to 5 machines of GeoEvent server running within a single site and support up to 30,000 events per second. So as you're bringing in higher and higher volumes of data, you need to be able to have an environment that can support that sort of data feeds requirement. Now the challenge becomes 10 machines. Okay, I need 10 machines to get this set up. That's a very difficult thing for most organizations to be able to maintain 10 machines on premise and be able to support this. So typically, when we start to get into this kind of volume, this kind of number of machines, most of our users opt to try and go for some of the cloud type deployments. It really simplifies this process. We have, through the rest of the ArcGIS Enterprise, we have builders, cloud builders, that allow you to deploy some of these environments in the cloud. It provides an easy to use wizard, allows you to set up the number of machines you want to use. Now for the 10.6 release of the ArcGIS builder for the cloud builder for Azure, it only supports single machine usage of GeoEvent server. For 10.6.1, it will introduce and include support for adding multiple machines. But the nice thing about this is you can provide your credentials, you can put in your signed certificates, you give it your names of the machines you want, let it kick it off, and everything's automated for you. So it really simplifies the process of standing up this environment. Now this is an example here showing what we have for Azure. We have a similar deployment story within Amazon as well. We have cloud builders for that as well that allow you to set that up in your environments. So I have some additional resources for you folks as you're starting to kind of go into this IoT space. The presentation that you guys have seen here today is a highly condensed version of a presentation that Adam and I gave at the user conference back in the summer. Basically took an 8-hour session. You guys got a 1-hour version of it. So I know there's a lot of material we went through today. Please feel free to go out to GitHub. That's the link there. That has all the slides from our 8-hour session. So you can see a lot of this information in significantly more detail if you want to take a little deeper dive into some of this content. We also have...
if you're interested in use cases of what people have done with IoT and ArcGIS, there's a whole section in that 8-hour content where our professional services presented different deployments that they've done for various customers.
So there's some example there for like Port of Rotterdam and some of the different larger scale IoT success stories that are in place. We have several sessions still to come available that kind of focus on real-time and big data GIS. There's another session this afternoon in Primrose A right behind you here that's focused entirely on leveraging the spatiotemporal big data store. So if you're looking at using that, I highly recommend that session. We have a session tomorrow morning in the demo theater, which is looking at some different web apps using the ArcGIS API for JavaScript. We have our big road ahead session tomorrow afternoon at 4 o'clock. I highly recommend that session. Kind of shows where, as a technology, where we're taking this at Esri. We have a session Friday morning on creating connectors using the GeoEvent SDK. So for those of you that are interested in kind of expanding some of our out-of-the-box capabilities with GeoEvent to either connect to additional data sources or additional kinds of processing, there's a session on that Friday morning. And then we have a repeat of a session we did just earlier today about some of the best practices for real-time and big data. So if you're already using it, kind of gives you some insight, kind of look under the hood of some best practices, some ways to avoid some gotchas when you're doing setup. So hopefully some really good information for that as well. We do have, for those of you, I'm sure you guys have seen these slides all week long. We do, request if, as you're going through the events app, please take a few moments to provide information on the survey. It helps us know what content you found useful, what content we need to go faster through or slower through, and helps us kind of make sure that we kind of tailor these sessions to something that's the most beneficial for you folks in the future. All of the slides will be set up and made available through the proceedings page, typically within a few weeks. So it's a good idea to bookmark this page and come back to it. And we just have a few minutes left in this session, but I'll open it up now for questions. And of course, Adam and I will stay here for a few minutes afterwards as well. If there's any other questions, you guys are welcome to come up for. Yes, in the back.
Great question. The question was, is there any plans to bring all this capability to ArcGIS Online? Come to the road ahead tomorrow. Yes. That is absolutely what we're working on. So we realize 10 machines is a lot for people to take on, so we want to provide this as a SaaS. Yep.
Any more? Well, thank you folks very much. We'll hang out here for a few more minutes. If you guys have any other questions, you're welcome to come on up. Thank you.